So the objective for this lesson is to find surface area. In this lesson, what we'll talk about is pyramids and cones. But to start, what I'd like you to do is I'd like you to pause the video, try the optional activity if you'd like to, opening activity, by going to the third page, picking one of the nets, the 4 nets that's listed on the last page, following the directions of cutting it out, taping it together, measuring it, and trying to find the surface area of it, and then we'll come back and talk about a few of them. So pause the video, try the opening. Now that we're back, let's go ahead and take a look at those 4 problems. So we'll scroll to the third page. Here's the first 2. The first one here has a square base with triangles on the side. It gets a total surface area of 33.25 square centimeters. The second one is a triangle base with triangle sides. So all the sides and the base are the same. You get a total surface area on that one of 23.68 square centimeters. We'll come back to that one in just a moment. And then the last 2, first one has a pentagon base, gives you a total surface area of 23.1 square centimeters. And then the last one has a hexagon base with triangles on the side with 28.8 square centimeters for the surface area. Now, notice the pattern with all of these is you find the area of the base, you find the area of one of the triangles on the sides, and then you add them all up to get the lateral area, add it to the base, and you get the total surface area. Let's use the green work here on the triangle base one here, on the right here as an example. So if you look at all these triangles being the same, we'll find the base area. I measured the base of this triangle as 3.7 centimeters, and then the height of each of them, since they're all the same, is 3.2 centimeters. So the area of the base is 1/2 the base times the height, so you get 5.92 for one of the triangles. So the lateral area will be the 3 triangles on the side that you fold up to come to a point to be a pyramid. Those would be 3 times 5.92 for the lateral surface area of 17.76. So lateral area being without the base itself is 5.92, so there's 4 of them in total. If you add those all up, you get that total of 23.68 square centimeters. So that's an example of doing one, and we're going to use that as a pattern for doing these types of problems. So when we look at this first problem, first of all, we're going to talk about what the lateral sides are. Lateral sides of a pyramid are triangles. So notice that you'll have a base, whatever your base is, could be different figures, but for the pyramid, all the sides are triangles when you add them up. So the surface area for a pyramid, surface area equals the area of the base, and then you add to that the number of sides on the base, because that determines how many triangles there are. So the number of sides times the area of a triangle face. Okay, so that gets us our surface area of a pyramid. Now, let's go ahead and try an example here. For this, we've got a square base here on this pyramid. And so what we're going to do to find this is, first of all, start by finding out what that slant height is, because this tells us that the height of the triangle, of the whole pyramid, is 24, which we could use if we're trying to find volume. But in this case, we need what the length of this slant height is, and I'm going to call that an L for the length along the face, that's the height of the face of the triangle, not the height of the pyramid. So to find that, notice that we've got this bottom side here is half of 16. That gives us an 8 for that side. So we're going to do the Pythagorean theorem. We're going to do 24 squared plus 8 squared is going to equal L squared. Slant height we'll use usually as an L. And then to add those together, 24 squared plus 8 squared is 640. That equals L squared. So L equals the square root of 640. Don't worry about the plus or minus because this is the side of a triangle, the height of a triangle. All right, now let's go ahead and figure out what the surface area of this. Let's start with the base. So surface area is going to equal the area of the base, which we're going to have as 16 times 16, added to, now there are 4 sides to that base, so we're going to have 4 times the area of each of the triangle faces. Well, a triangle face, you're going to get 1/2 times the height, which is that slant height. Okay, that slant height is 640 times the base of the face triangle, which is a 16. I can even write it over here saying that that triangle that we're looking at has 16. So we got 4 of those faces, and when we calculate that out, we get 256 plus 4 times, and we're going to multiply this out, and we get 32 times the square root of 640. And then when we do that on our calculator to get an approximation, we get 1065.5 units. That's our answer for the surface area. Base plus the faces gives you the surface area. All right, now let's talk about a sphere. Sphere is totally different. It's just a formula that we're going to use. This is not a formula that we're going to memorize. Instead, we're going to just have the formula to use. The surface area of a sphere equals 4 times pi times the radius squared. So all we need to know is the radius of our sphere, and then we'll substitute that in to get what our surface area is. So the surface area of our example here, notice that that has a diameter of 10, so our radius is 5. So we're going to have our surface area equal 4 times pi times 5 squared. And that's going to equal approximately, if we were to round it to 1 decimal place, 314.2 square centimeters, since we have centimeters as our units here. So that's a sphere. So now we've done a pyramid and a sphere. Next up is working on the cone. Notice I've shown you a net here of the cone, so you can see that the cone has a circle base, and then you wrap that other area to get this lateral area of it, which is not a very intuitive formula. So what we want to do is we want to list for the to use in this. We're going to have as our part of our formula the slant height. So I'm going to use L for my slant height again. And so what I need to use for surface area of a cone, that equals pi times the radius times the slant height, which is L, plus, that's the lateral area, and then plus pi r squared, which is the base. Okay, so this is the base area here, and this is the lateral area here. Okay, so let's try this example here. So when we do this, first of all, we need to have the the slant height. So we've got on this a height of 8, and the other leg of the triangle is 4. So we're going to have 8 squared plus 4 squared is going to equal, and if we call the slant height L, L squared, 8 squared is 64, 4 squared is 16, and add those together you get 80. So we're going to use, I'm going to write it over by where we're going to do the problem. So I'm going to use the my slant height, which is going to be the square root of 80. And if I put that into my surface area of a cone, I get pi times r, which in this case the radius is 4, times the slant height, which is 80, square root of 80, plus the area of the circle base, which is pi times 4 squared. And when I multiply that out on my calculator to one decimal place, I get about 162.7 square inches. So to find the volume of a cone, the surface area of a cone, you use pi RL plus pi r squared, and use that as well as what we had for our formulas for our surface area of a sphere is 4 pi r squared, and our surface area of a pyramid, which is the area of the base plus the number of sides times the area of each triangle face, and you have each of those surface areas.